Okay, so we're making these notes to help us learn the ways that we can prove triangles similar. So last chapter we talked about proving triangles congruent. That means they had exactly the same corresponding angles and exactly the same corresponding sides. And we had 5 ways we proved them congruent. You just got that test back, right? This chapter we're learning how to prove triangles similar. That means that they have all corresponding congruent angles, but the sides are proportional. That means they have the same ratio. They're same shape but different sizes. So in case you've forgotten what that means, you might want to make a reminder somewhere that similar, which is this symbol right here, means same shape. Shape is the same, but size is different. Like the example here on the front of our little notes that we're doing, right? Similar triangles are often used in measuring things that cannot be measured directly. You'll notice the picture on the front of these notes shows a tree and its shadow with a little kid and his shadow. That's because part of what you're going to be doing is learning about indirect measurement. How do you think they get the heights of like really tall things like mountains and stuff? Okay, so using some right triangle trigonometry type of stuff is a good way of finding the heights of things that are too tall to measure directly. But the way we're going to learn in this chapter is just doing similar triangles, because you'll notice that this tree and its shadow kind of create one triangle, and the kid and his shadow create another triangle. And if you measure the shadows like at approximately the same time, when the sun's at about the same angle, then your triangles will have the same angles, and therefore they will be similar. And so you can set up ratios to solve, okay? We'll be looking at that today. Like, for example, consider that that's the height of the tree X, and you measure this length here, and you know your height, and you measure this length here, then as long as you've got these lengths and this length, you can set up ratios to solve for X, cross multiply. So that's going to be kind of a applied thing that we're learning. Okay, there are 3 ways to prove triangles similar. The first rule is called angle-angle. If 2 angles of one triangle are congruent to 2 angles of another triangle, I'm just going to draw a picture of a triangle to abbreviate. Then the triangles are what we call similar. They will be the same shape but different sizes if we don't know that the lengths are the same. Okay? If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Why do you think it's only 2 angles and not 3? Why do you think just 2 angles and not all 3? In geometry, we like to use as little information as possible. So 3 angles would be great, but 2 angles is enough. Any ideas why 2 angles is enough? What does every triangle add up to?
360. Or is it 180?
Every triangle adds up to 180. So if you know that 2 of the angles are the same, what do you automatically know about the third angles? They automatically have to be the same. So 2 angles is enough because the third angles will automatically be congruent as well. So that's just as little information as possible to get the job done. Okay, so let's suppose that in this triangle, this angle is 65 degrees, and this angle is 40 degrees, and this angle is 65 degrees, and this angle is 40 degrees. I'm going to label these A, B, C, D, E, F. Okay, so to show our work on this problem, what we would do is say, oh, well, angle A is congruent to angle F, and angle B is congruent to angle E. Therefore, we have two angles congruent. Therefore, this little triangle of dots like that means therefore. If you want to use it, you can. You don't have to. Therefore, triangle ABC is similar to triangle what? We have to be really careful of the order we write stuff in. How do they match up in this case, the way I drew them? A is what I wrote first, and A goes with, I heard someone say it, F, and then B goes with E, and C goes with D, right? So in triangle FED, by the angle similarity postulate. Okay, that's kind of a lot to write. So most of the time, well, you do want to say you've got your angles that are equal. You have to have your similarity statement. That's what that part is called. And then you need to write angle, even if you don't write all the other little words that I've put in there. Okay?